Hello everyone, and today I'm here with the continuation of our lecture on probability of single events, and today I'll be discussing few more questions regarding probability. I'll be recalling few concepts and then we will be applying it to the questions. So first of all, let's recall the important points that if the probability of any event is 0, it is impossible to happen or it will never occur, and if the probability of any event is 1, it is certain to happen or it will definitely occur. These were the points discussed in the previous video as well, that the probability always remains between 0 and 1, and if we talk about probability of any event as 0, it means it will never going to happen, and if the probability of any event turns out to be 1, that means it is 100% happening. So the probability remains between these values. And to find the probability, we use these two formulas, that probability of any event is number of favorable outcomes for event over total number of possible outcomes. This is discussed and used in the previous videos as well, but I will be discussing it here as well with the questions. And this is for probability of obtaining that event do not happen, any particular event that is not happening. So let's proceed with the questions. So this is the first question, that we have the letters of the word probability written on a card, and each alphabet is written on a single card, and I have well shuffled it and put it on the table. So I need to obtain the probability of these four tasks, that the probability of getting a alphabet A on the card, and B, and vowels and consonants. So let me recall you what are vowels. Vowels are the alphabet that is A, E, I, O, U to be specific, and the consonant, the alphabets other than the vowels are the consonants. So when I talk about this, firstly the sample space, that how many cards I have been given. So I can see this, that I have a P, R card, O card, and this is B1 because we have two B's here. So I've differentiated it by B1 and B2, and here's A, and then we have two I's, so this is I1, I2. So this is total of 11 cards I have, which completes this verse probability. So the total possible outcomes are 11, and I need to obtain a A. So how many A's are present in this possible outcomes? There is a single A out of 11. So the probability of getting an A is favorable outcome is 1 card, and the total outcomes are 11 cards. So the probability would be 1 over 11 for obtaining an A. That is 1 over 11 written here. When I talk about probability of getting a letter, getting B, that means I have this B1 and B2, both cards can be obtained. It will be written B on it. So the probability of getting a B is 2 over 11. So here it is. The probability of B is 2 over 11. Then when I talk about vowels, I need to find the vowels in this spell. That is this O, this A, two I's. These are the vowels, and I have seen it that the vowels are 4 out of 11, so the probability turns out to be 4 over 11. And if the probability of vowels are 4 over 11, other than that are the consonants obviously, so the probability of consonants are 7 over 11. I can count those consonants, and they are 7. So this was the first question. Now discussing another question regarding this, that I have an envelope of 40 shopping vouchers, out of which 25 vouchers are of $50 and 15 vouchers are of $100. I need to find the probability of picking a voucher of $100. So I have the sample space as I have $50 vouchers, 50, 50, 50, and I have put a dot over here because I cannot write so much vouchers. It is 25 vouchers of 50. So these are 25 times 50, and these hundreds are 15. because there are 15 vouchers of 100, so total of 40 vouchers, so total possible outcomes are 40. And when I talk about the voucher of 100, they are 15 out of 40, so the probability would be 15 over 40. Now what's new in this, that in the previous cases we are obtaining a fraction which cannot be cancelled with the same table, or it cannot be simplified. Here it can be simplified, that so we need to simplify it to get our answer. So this would be 3 over 8. We will cut it by a table of 5. 5 3s are 15 and 5 8s are 40. So we need to give the answer in the lowest form. We need to simplify the fraction and get the answer to the simplest form. So let's move to another question. So this is a question of a 2-digit number is chosen at random. Find the probability that the number is less than 20 and a perfect square. So first of all, let us know the sample space. When I talk about 2-digit number, 2-digit number starts from 10 and it ends at 99. Because after 99 it is 100 and it is a 3-digit number, and before 10 it is 9, that is 1-digit number. So we have a sample space of 10, 11, 12, 13 and it is continued till 99. So the number of possible outcomes are 90, starting from 10 ending till 99. So out of this I need to obtain a number which is less than 20. So less than 20 are the 10 numbers: 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, and less than 20, so 20 would not be included. So I will write the probability as 10 over 90 and I will cancel zeros. I will cancel it with on a table of 10 and I can obtain 1 over 9. After that, when I talk about the perfect squares, so perfect square are the numbers. When I talk about squares, if I take the square of 2, I will obtain a 4. 2 square 4. And when I talk about 3 square, that is 9, and so on. So I can check for the values. That is, when I talk about 3 square, it is 9. So the value, starting from 4, 4 square is 16, 5 square is 25, 6 square 36, and so on, and it will end up at 9 square, that is 81. After that, when I talk about 100 square, it is 10 square, it is 100, which exceeds our limit of 2-digit numbers. So we have 6 perfect squares in these, and out of 90, and I have cancelled it again in a 6-time table, so the answer turns out to be 1 over 15. So let's look at another question. So this is something like a bigger question, but a simpler one. In this question we have a table, and we have been given a school data that a managing staff has 26 person in them, teaching staff has 62 persons, laboratory staff and admin staff and maintenance staff. So this is a school having this number of people in their staff members, as their staff members. So we need to obtain a probability of getting a teacher. So I need to pick any one person out of these total. So we need to obtain a teacher or management staff or admin, and this is the case B, which I will discuss a bit later. So first of all, I have copied this table, this question, and then I will first count how much is the total for the staff. That is, when I add them all, I got the value as 117, which is the total number of members present in the staff. And I need to obtain the probability of getting a teacher. So a teacher there are 62 teachers out of 117. So the probability turns out to be 62 over 117. After that, we can cancel if this is going in a single table, but here it is not, so I have kept it here as the same. After that, when I talk about the management staff has 26 persons out of 117, so the probability of management staff would be 26 over 117, which is cancelled to get 2 over 9. The third part has an OR between them, and I have discussed in the previous video as well that when I talk about OR, the OR means we need to add up both the probabilities, the first one and the second one, when there is or in between. So administrative staff, the probability of getting an administrative staff is 9 over 117, that is cancelled to be 1 over 13, and the maintenance staff is 12 over 117, so it is cancelled to 139. And when I talk about the collective probability, and it has an or in between, so we will add both the probabilities. We can take the LCM and we can add them to obtain 7 over 39. So talking about case B, in this case we have been given that 2 teachers and an admin staff resigns from the school. That means 2 teachers are less now, that the 60 teachers. And when I talk about the admin staff, 1 admin staff member has left, that means it makes it 8. So when I was talking about the previous case, it was when we add them up, it was 117. But now when I talk about -2, or in the teacher column, the teachers in the school remain are 60 and administrative staff remain in the school is 8. So now the total outcome becomes 114. 117 is reduced to 114. So this is for part A, and now this is for part B. When I talk about the probability of getting an admin staff now, so admin staff is 8 out of 114. So the probability of administrative staff is 8 over 114, and this is cancelled to 4 over 57. When I talk about the laboratory staff, this is not a laboratory staff. We need to obtain not a laboratory staff. That means we can obtain the probability of every other staff other than the laboratory staff. That would be a very larger process to be done. So we can calculate the probability of laboratory staff first, and we can subtract it from 1, that is 100% of the value. So we have obtained the probability of laboratory, that is 8 over 115, and then I have subtracted it from 1 minus laboratory of staff, that the formula I discussed in the video before, that when if we need to obtain any probability not happening, so we need to subtract 1 minus that probability of happening of the event. So we have subtracted it by taking an LCM and solved it to get the answer of 106 over 114, and this is cancelled to get 53 over 57. So these were the questions for today, and if you have any other question, any other query, please comment below. Thank you everyone.